Share.
Good afternoon, everyone. Let us discuss some more problems on volume integrals. Okay. Evaluate triple integral over V x y square z dx dy dz taken through the first octant of the sphere x square plus y square plus z square is equal to a square. So here we have to find the volume of this volume integral of this integral x y square z dx dy dz. Okay, so here the sphere is x square plus y square plus z square is equal to a square. Observe that it is a sphere having center at the origin. Okay, x equal to 0, y equal to 0, z is equal to 0 is the center of this sphere and having radius a. So x square plus y square plus z square is a sphere having center at origin and having radius a. Now we have to evaluate this volume integral. Okay. So coming to the sphere, in the first octant, x is positive, y is positive, and z is also positive. So in the first octant, x values in general varies from 0 to infinity, and y from 0 to infinity, and z also from 0 to infinity. So here, but we need the volume up to the sphere only. Okay. So for this one, so value x square plus y square plus z square is equal to a square. From this, we can write z square is equal to a square minus x square minus y square. So, z is equal to square root of a square minus x square minus y square. So here I am not writing plus or minus root of a square minus x square minus y square. Since in the first octant z starts from 0 only. Okay. So z is equal to 0 to square root of a square minus x square minus y square. So these are the limits for z. Now whenever z is equal to 0, we can write x square plus y square is equal to a square. Okay, from this one, y square is equal to a square minus x square and y is equal to root a square minus x square. So therefore, in the first octant, y starts from 0. So 0 to root of a square minus x square are the limits of y. Similarly, whenever this y is also 0, we will get a square. X square is equal to a square. This implies x is equal to a. So in the first octant, x also starts from 0. So the limits of x are 0 to a and y 0 to root a square minus x square and z from 0 to a square minus x square minus y square. Therefore, the given integral over v x y square z dx dy dz. This can be written as triple integral. So where the value of z is from 0 to root a square minus x square minus y square and the value of y is from 0 to root a square minus x square and the limits of x are 0 to a. So triple integral over v means z from 0 to root a square minus x square minus y square, y from 0 to root a square minus x square, x from 0 to a. Here the integrand is x y square z dx dy dz. Okay. Now we have to evaluate this integral. Okay. Now for this one, now we have to integrate this integral. Look, observe the limits here. The first limits are for z. So first of all you have to integrate this one with respect to z. So this can be written as, this is equal to integral 0 to a, integral 0 to root a square minus x square into integral 0 to root integral 0 to root a square minus x square minus y square. Okay, so first of all you are going to integrate with respect to z. So only z dz. So while integrating with respect to z, x is a constant, y square is a constant. So that can be taken outside the integral. So here first of all we have to integrate with respect to z because the limits are for z is 0 to a square minus x square minus y square. So x y square into again dx dy is remaining. Now we have to take integral of z with respect to z only. So integral of z dz is equal to which is equal to double integral. Integral of z is z square by 2. Integral of z is z square by 2. Between the limits 0 to root a square minus, between the limits 0 to root a square minus x square minus y square into we are having x y square dx dy. So the limits of y are, y is from 0 to root a square minus x square. The limits are x is equal to 0 to a. Okay. So this is equal to integral 0 to a and integral 0 to root a square minus x square. Integral, you have to substitute the upper limit first. At z is root a square minus x square minus y square whole square by 2 minus lower limit is for z is 0. So 0 square by 2 into dx dy. So this is equal to x is from 0 to a, y is from 0 to root a square minus x square. So here square and square root gets cancelled. So here the value remaining is a square minus x square minus y square by 2 minus 0 square is 0 by 2 is 0, 0 by anything is 0. So 0 square by 2 is 0. So did not write the second term into dx dy. Here we have into xy square. Here also xy square. Okay. So now we have to integrate the next one. First of all, in the first step, we have integrated with respect to z. So integral 0 to root a square minus x square minus y square z dz. Integral of z is z square by 2. So the limits are 0 to root a square minus x square minus y square. So here in place of z we have to substitute the upper limit. So it is root a square minus x square minus y square whole square by 2 minus in place of z we have to substitute the lower limit which is 0. So 0 square by 2. Okay, so into xy square only dx dy dx dy. So square and square root gets cancelled. 0 square is 0, 0 anything is 0, so the lower limit value is 0. So totally this value is a square minus x square minus y square by 2 into dx dy. So here 2 is a constant, so it can be taken outside the integral. So this is equal to 1 by 2 into next variable of next look at the limits. Next the limits are for y. So we have to integrate with respect to y. Now Now for this one, while integrating with respect to y, we have to treat x as a constant. So here x is from 0 to a. So x is also a constant. So I am writing outside this one. Now integral y is from 0 to root a square minus x square. So we have here y square into a square minus x square minus y square into dy into dx. Okay. Now we have to integrate this one first. That means with respect to y first, because the next limits are for y, which are in terms of x. So integral y is from 0 to root a square minus x square y square into a square minus x square minus y square dy into dx. So look at the two terms here. A square minus x square power 5 by 2 by 3 minus a square minus x square power 5 by 2 by 5. So from these two terms we can take a common a square minus x square power 5 by 2. So this is 1 by 2 into integral 0 to a x into a square minus x square whole to the power 5 by 2 into from the first one we can take a common a square minus x square power 5 by 2. So here what is remaining? 1 by 3 is remaining. In the second term 1 by 5 is remaining. So 1 by 3 minus 1 by 5 into dx. So 1 by 3 minus 1 by 5. So 3 into 5 is the LCM. So 5 minus 3, which is 2 by 15. So which is a constant. So it can be written outside the integration. So which is equal to 1 by 2 into 2 by 15. 1 by 2 into 2 by 15 integral 0 to a x into a square minus x square a square minus x square to the power 5 by 2 into dx. Okay, this one. Here 1 by 2 is constant, 5 minus 3, so which value is 2 by 15. So 2 by 15 into x into a square minus x square to the power 5 by 2 into dx. Now we have to finally integrate this one with respect to x. Now to evaluate this one, I am taking a square minus x square is equal to some t square. So what substitution I am taking here? A square minus x square is equal to some t square. Now whenever we have taken substitution, we have to change each and every one. We have to find dx, the derivative of x from this, and we have to change the limits also. So a square minus x square is equal to t square. Differentiating both sides. Derivative of a square minus derivative of x square is equal to derivative of t square. Since a is a constant, which is the radius of the sphere, so here derivative of a square is 0. Derivative of constant is always 0 minus derivative of x square is 2x into dx, because the derivative of x power n is n into x power n minus 1. So derivative of x square is minus 2x dx. Derivative of t square is 2t into dt. So here 2 minus 2x dx is equal to 2t dt. Cancel 2 on both sides. Minus x dx is equal to t dt. From this one, x dx is equal to minus t into dt. Now we have to find the limits also. Lower limit. Coming to the lower limit, so the limit of x is 0. So the lower limit of x is 0. Whenever x is 0, t square is equal to a square minus x square. So a square minus 0 square, this implies t square is equal to a square. So t is equal to a. Coming to upper limit. Okay. So whenever x is equal to a, we have t square is equal to a square minus x square, which is a square minus a square, which is equal to 0. So t is also 0. So the limits are, the lower limit is t is equal to a and the upper limit is t is equal to 0. Now substitute these values in the integral. Here 2 gets cancelled, 1 by 15 into. So new lower limit is a, new upper limit is 0. So integral a to 0 x into dx. In place of x into dx, we can write minus t dt. Okay. Next, a square minus x square. A square minus x square is t square. So in place of a square minus x square, write t square to the power 5 by 2. So in place of x dx minus t dt, and the new lower limit is a, upper limit is 0. So we have substituted all those values here. Here t square power 5 by 2. This minus is also constant, so it can be taken out. Minus 1 by 15 into integral 0 to a square root and power 5 by 2. So this t power t to the power 2 into 5 by 2. Since a power m whole power n is equal to a power m into n, here 2 gets cancelled. This is t power 5. So t square power 5 by 2 is t power 5. So here I am writing t power 5. So this minus I wrote before the integral. Next, what is remaining? T into dt. And we know one rule that integral a to b f of x dx is equal to minus integral b to a f of x dx. So by using this theorem from your intermediate, okay, so here minus integral a to 0 can be written as integral 0 to a 1 by 15 into t power 5 into t. A power m into a power n is a power m plus n. So t power 5 plus 1, which is a t power 6 into dt. Again in the form of integral of x power n. Integral of x power n is x to the power n plus 1 by n plus 1. So this is equal to 1 by 15 into integral of t power 6 is t power 6 plus 1, 7 by 7 between the limits 0 to a. So this is equal to 1 by 15 into the value of upper limit is a to the power 7 by 7 minus lower limit is 0 power 7 by 7. So this is equal to 1 by 15 into a power 7 by 7, which is equal to a power 7 by 105. 15 sevens are 105. So therefore the value of the given integral is a power 7 by 105.